Interesting facts about the James Webb Space Telescope. Let's be honest here for a second, the James Webb Space Telescope, JWST, is one of the world's most significant technological marvels. Not only is it a highly advanced telescope, but it's also operating out in space and sending back data to Earth. If you've been wondering what all the hype surrounding the James Webb Space Telescope is about, get ready to have your mind blown with some out-of-this-world facts. The James Webb Space Telescope is named after NASA's second administrator. Originally called the Next Generation Space Telescope, the JWST was renamed in 2002 in honor of James E. Webb. As the highest-ranking official for NASA from 1961 to 1968, Webb developed NASA from a disconnected organization into the highly coordinated machine it's now known to be. Webb also oversaw the Mercury and Gemini programs and most Apollo programs. Naming the JWST after Webb was controversial, as he had been accused of being complicit in systematically firing any employees suspected of homosexuality. It took 26 years to go from a proposal to deployment and fully operational. The JWST's road to completion was rocky, to say the least, considering it was proposed in 1996 with a launch date of 2007. The mission was replanned multiple times due to skyrocketing costs, which delayed it even further. In 2011, 4 years after the initial launch date, the JWST's design phase was over, and construction of its parts began. 5 years later, it was finally put together, and testing began. In 2018, the telescope's sun shield ripped during testing, with a review finding 344 possible single-point failures. The following 4 years were spent finding solutions and retesting everything. The fact that it launched in 2022 is incredible. The JWST's instruments allow it to capture images of objects 100 times less bright than the Hubble Space Telescope could. The JWST has 4 scientific instruments: a near-infrared camera, a near-infrared spectrograph, a combined mid-infrared camera and spectrograph, and a combined near-infrared camera, spectrograph, and guidance sensor. These 4 instruments give the James Webb Space Telescope unprecedented abilities to gather data on the universe and its beginnings. The James Webb Space Telescope can see back in time. When the first galaxies were formed, the light they emitted was in the visible spectrum. The longer and further light travels, the more it shifts into the infrared spectrum. As the JWST captures images using infrared sensors, it's able to capture the light of the first stars that formed like no telescope before it could. The ability to look back at the origins of our universe is one of the most significant features of the JWST. It can also see right through clouds of space dust. Space has dust too, and this dust gets in the way of regular telescopes. This is particularly bothersome, as a lot of dust is kicked up when galaxies are forming. As infrared light can move through dust clouds easier than light in the visible spectrum, the JWST can capture better images of galaxies being formed than any other telescope. The James Webb Space Telescope must be kept below -370 degrees Fahrenheit, -223 degrees Celsius, to function correctly. The thing with infrared telescopes is that any form of heat can render them useless. It's why we can use infrared telescopes on Earth or the Hubble Space Telescope. There's just too much heat interference. Space is actually colder than the telescope's working temperature, but that's only the case for objects that aren't being touched by the sun's light. To counter this, the JWST has a sun shield made of 5 layers of reflective film as thin as a human hair to reflect the sun's light to prevent it from interfering with the highly sensitive instruments. As the telescope has to remain in the shade of the sun shield at all times, it can only ever see 40% of the sky at once. The JWST sits in a stable orbit 1 million miles, 1.6 million kilometers, from Earth. It's not orbiting Earth, though. Due to its need to always be shadowed from the sun's light, it's been placed in the sun's orbit in a position called a Lagrange point. A Lagrange point is a unique position in space where one object can easily stay within a relative location to another. In this case, the JWST will essentially be able to stay in orbit around the Sun in a fixed relative position to Earth with only the occasional need to adjust its motion. To fit into its launch vehicle, the JWST had to fold up like the world's most expensive piece of origami. When combined, the telescope's mirrors alone are 21 feet, 6.5 meters, in diameter, and the sun shield is about 46 by 70 feet, 14 meters by 22 meters. While the amount of space within a rocket for a payload is considerable, This would never have a chance of fitting. The solution, in the end, was both highly sophisticated and elegant. The entire telescope folded in upon itself. After it finally reached its destination, it took an incredible 2 weeks to slowly unfold, piece by piece, before any of its instruments could be tested. The JWST's launch and deployment went so smoothly that its expected mission length was doubled. A tiny amount of fuel is required to keep the JWST stable in its orbit around the Sun. Conservative estimates of the fuel necessary to position and deploy the telescope gave the mission about 10 years of life. Ariane 5, the JWST's launch vehicle, was so accurate in the telescope placement that much less fuel was required to get the JWST to its position. As fuel is the only thing holding the James Webb Space Telescope back from operating for much longer, this is a monumental achievement that NASA could only ever have hoped for. One of the most exciting things about the James Webb Space Telescope is the thought that generation upon generation of current and future scientists, astronomers, and regular folks like you and me will benefit from it. While we gaze up at the night sky, the JWST will peer right into the depths of it. We're as close as we've ever been to learn the true origins of our universe, and it's all thanks to this incredible piece of machinery. Leave a thumbs up on this video if you did that. It does help massively with the algorithm and helps me release more exciting videos for you to see. Don't forget to hit the subscribe button. Smash the like button and ring a notification bell. What is your overall opinion of this video? Don't forget to share your opinion below. Bye friends and see you soon.